All right, let's take a look now at inequalities. So for an inequality, first graph where the line is going. I see that because there's no small line underneath it, that means this is a dashed line. So I need to figure out where it goes. So 0 in the middle, and then I'll do, say, 2, -2. The square root of 0 is 0. Ooh, if I do 2s, that means I'm not getting 50 squares. I'm going to change this to a larger number. Negative. So now if I put a 4 inside, the square root of 4 is a 2. And -4, ooh, I can't use that. I can't use -4 because that would give me the square root of -4, which means there's an I in it, and it's imaginary. So instead, let's go on from the 4, 5, 6, 7, 8. If I do 9, square root of 9 is a 3. So let's plot some things here. 0, 0, 4, and 2, and 9 would be a little off and a 3. And it's a dashed line. Now, what we need to do is pick a number that we can put in there because this is the equivalent for practical purposes of y equals square root of x. So we need an x and y value, but not one that's going to cause us, well, actually, let's just take this one. That's clearly in on one side, and that's going to be at 4. And 0, let's see, is 4 and 0, yes. So that means that our y value is 0. Oh, I need to put, this is where it is less than or equal. Sorry, I did not mean to show that way. So that means that y is less than, and because the square root of x, actually we don't know what it's going to be there now. So, whoops, y is less than that. Well, let's just find out, is it true? If this is a true statement, we'll shade on the inside. So for the y, I put in the 0, less than, square root of, and 4 goes in here. Okay, so it's 0 less than 2, which is true. So I would put it where this is being shaded here. Now there's an important thing to realize with the graphing. And that means that because the domain is restricted, oh, we should write out the domain. Because the domain is starting at 0s and going up to infinity. And the range, the earliest number to start with for that. Well, actually, the range on this we can see would be the all the numbers that are 0, 0, and going to negative infinity. Now, in an inequality, these are not as much of a deal for us to be considering, although there's certainly a wide range of numbers there. We actually have to show the shaded area like this problem does. Here's the thing to recognize. This part here, okay, doesn't get used. Okay, because for that one here, let me go back with this. Okay, for that one in green, we cannot have any x values over here, or the square root of x negative. And therefore, we can't use this area. So you can't just shade below the line and over on that side. You have to shade only below the line, including going from 0, 0 on down. So this would be the answer, would be to show the shaded area with or without the writing in there. Well, now on the next one, so we need to figure out where is this. Let's look at the starting point. We have a +2 and a -5. So I'm going to go to +2 and -5. And then I'm going to go up 1 to a +3, which square root of 1 is 1. 1 take away 5 is -4. So that oh, I put in 3. So if I use x equals 3, So then for 3, I get a positive 1, I get a negative 4. So at 3, I get, that one first one. So 2 and negative 5, 4, 5. And then it's 3 and negative 4. And now let's pick another number, give us a square root of 6. So let's say that x is equal to 6. Square root of 6 minus 2 minus 5. That's square root of 4 minus 5. That's 2 minus 5. And that makes negative 3. So that means we get the point of 6 and negative 3. So 3, 4, 5, 6, and negative 3. Oh, I just noticed, maybe that I did. This can not be a solid line, it needs to be a dashed line. That is easily remedied this way. There we are. Now we need to figure out where to shade. We know we don't have to look at anything that's over on this other side. Nothing over here, because of the fact that our domain or starts here and goes that way. It has to go larger. So that means if we want to pick a number, we either pick a number from this area or pick a number from this area to test it. Okay, now I find I want an x value to give me a square root in there. So why don't I take this pick point here, which is way above the line, and we'll either shade everything above or we'll shade everything below. 2, 3, 4, 5, 6. So the x value is 6, y value becomes unbelievable. So just to see that if you put this in the graphic calculator, down 5. So let's take those numbers. This is 6 for the x and 0 for the y, and let's actually put it back in here. So I'm going to do it in here. This is a y. So the y value is 0, and is that greater than square root of 6 minus 2 minus 5? 6 take away 2. It's 4. Square root of 4 is 2. 0 greater than negative 3. That is a true statement. If that's true, then we're going to shade this part, not going past the domain into the negatives. Okay, there. So that's the correct answer, is that shaded area. Now that's what you have to show. Remember, must stop at that line. Okay, so the blue area is the shaded correct area. Every point there will satisfy this original equation. And there's a million points. There's an infinite number of points, actually. Okay, let's look at this practice one. So I see first that this is going to be a dashed line. And actually, having said that, you might want to stop the video for a moment, go and do it yourself, and then come back, because as soon as you turn it back on, I'm starting to talk again. Here we see that our starting point is negative 3, negative 4. So if I go to negative 3 and 4, it's here. And if I do an XY table, I can get the other points. So negative 3 is negative 4. Let's do one larger number. That will give us a square root of a positive 4. Take away 2 minus 4. 1 take away 4 is negative 3, except that that's not allowed. Not, well, actually, it's just helping us get the negative 3. So negative 2, negative 3. Now, let's go to another number that will give us a perfect square in there. So let's say x is 1 will work. So 1 plus 3 is 4. Minus 4, that's 2. Minus 4, which is a negative 2. So at 1, we're at a negative 2. And then let's use the dashed line for that. So now we need to know which side to shade. We already know that we're not going to be here. Okay, so that's no, no. Actually, let's make all that native one. They tell us 0. So no in this area. No in this area, so we can't shade in those areas. So let's use a point like 0, 0 here. And this side, yeah, I guess that one's good. Okay. So if I use this to test the point, problem with testing that is I don't get a perfect square in the inside. So I think what I want to do is test it when the x is 1. It's still above the line, but now I know the x is 1. So that's at 1 and 0 for the y. So I want to come back here and make that y 0 less than square root of 1 plus 3 minus 4. 0 less than square root of 3 is, well, 1 plus 3 is 4, square root of 4 is 2. 0 less than a negative 2. Well, is 0 less than a negative 2? No, it's greater than a negative 2, which means we can't use this area where 0, 0 is, but we can shade automatically the other side right up to the stopping point, but not including the stopping line. But every point on there is now showing one that will satisfy this equation, or rather this inequality. Well, thank you for watching and listening, and I hope that helps with understanding how to graph a basic square rooted number. Flexion, stretch or shrink, and inequalities where we have to shade one side or the other, or one up or one down. And remembering there's a stopping point in each one, so someone doesn't try to get in. Bug someone who's working on this. Can't use these areas. That's one of the euphemism ways to think about it. Anyway, you now know quite a few things about working with inequalities, graphing them, having square root equations, then square root inequalities, and looking at what the domain and range is. And I hope this is helpful. Thank you for watching and listening.